Hello, good morning, happy Thursday. And so, as I had previously stated, I am not able to be in today. I am currently in Newark doing just some wonderful math teacher stuff. Um, you've at this point had some time to work on the do now, so we're going to quickly run through the do now. Um, and so, starting with number one, here we are. If we're solving for n in the equation below, right, that means that we are looking to isolate n. Now, taking a look at this, the first thing I notice that needs to happen is I need to be able to distribute this 2 fully in to these parentheses. And so I'm going to be left with 20 is equal to 2n minus 2 plus 6. I'm going to go ahead and clean up these like terms. 20 is equal to 2n plus 4. Right, 6 minus 2, or negative 2 plus 6. Subtract 4 on both sides. 16 is equal to 2n. From here, go ahead and divide both sides by 2 to learn that n is equal to 8. All right, up next, I quickly just want to stamp number 3, right? We've talked about independent variables and dependent variables a bit this week, specifically in context of direct variation and their use with units and x and y. And so if she tracks the number of miles y she can run in x number of hours, identify each of the following. Well, the question actually does some of the heavy lifting for us and already identifies what x and y actually are. And so as a reminder, we always make x our independent variable, or our IV, and y our dependent variable, or our dv. And so if we're thinking about what they actually are, we're going to have number of hours, and then we are going to have miles for dependent. All right, with that, go ahead, have your notes out in front of you. Go ahead and pause the video if you need to. Alrighty, so today we are looking at a wonderful new topic that's going to tie in really well with where we're going as we move forward, called arithmetic sequences. And so arithmetic sequences have sort of a wordy definition, and so please feel free to pause this whenever you need. And so an arithmetic sequence is a sequence which has a constant difference between each term. And so it's a sequence which has a constant difference between each term. And then we have some pieces here, a sub n, a sub 1, n, and d. And so again, the way that we're going to say these and read these, this is a sub n, a sub 1, n, and then d. And each of these have really, really specific names and parts that they play. And so a sub n is going to be what we call the value of the nth term. It's the value of the nth term. And so a sub 1, well, that's the first, or starting, I'm going to put starting in parentheses because we'll see it both way, term. N is going to be our term number. And D is that piece that we've already sort of seen up above, this constant difference. And so we're going to take a look and see how on earth do we put all of these together. There we go. There's a smoother slide than I had wanted. Wonderful. With all of these pieces, and when we look at arithmetic sequences, we actually end up creating a formula. Now, this formula is always going to look the same. And so we're going to have the general form. And that general form is a sub n is equal to a sub 1 plus, in parentheses, n minus 1 times d. And so it's this value of the nth term that we're going to be looking for. And that's going to be equal to our starting term plus the common difference times whatever term we're looking for minus 1, right? Think of this as we take our starting term and however many times we've actually added it, that's this n minus 1 times d. Because remember, that repeated addition is really just multiplication. And so let's sort of see this in action. And so on example 1, we're really just looking to see if these terms are actually arithmetic or not. Looking at this, the piece that I'm going to be looking for is how are we actually going from term to term. And so going from 1 to 2, okay, well, I'm adding 1. Going from 2 to 4, oh, hang on a second. Now, apologies. 2 to 4. Now I'm adding 2. Okay, let's check the last one just in case. From 4 to 8, well, hang on, because now I'm adding 4. And so since these pieces aren't constant or are not the same, we would say that this is not arithmetic, no common difference, right? That constant isn't actually constant. And so we would say that this isn't an arithmetic sequence. All right, let's take a look at number 2. Now, number 2 is going to stretch our brains a little bit because I have to figure out how do I go from 1/2 to 1/4. Well, in order to get a better idea of what's going on, I'm actually going to change 1/2 into fourths. And so I can actually just rewrite this 1/2 as 2/4. Oh, okay, well, if I go from 2/4 to 1/4, I'm actually subtracting 1/4. Okay, and now if I go to 0, well, hang on a second. I'm subtracting 1/4 again. And now going to negative 1/4, well, again, I'm subtracting 1/4. And so we would say, well, yeah, take a look. We're subtracting 1/4 every time. That means that I do have a constant rate of change here. And so, yes, there is a common difference. Feel free to pause if you need. We're going to wait to do example 2 until after problem set A. And so once you have this, we're going to jump back to our packet and be taking a look at problem set A. It's only 4 questions. And so for the 4 questions, you're going to have probably around 5 minutes to work silent and solo. Go ahead and start, and feel free to pause the video. All right, and so you've had some time to work on problem set A, and we're going to fly through some of these answers because I'm hoping that these were a little bit less challenging than maybe some of the notes let on that they might be. And so if we're just looking for the common difference, right, we're looking for this D value. And what we're really seeing is how are we going from one number to the next? Well, 5 to 8 to 11 to 14. Well, we're adding 3, and adding 3. And so that means that D is going to be equal to 3. For number 2, we just have to be really careful, right? If we think about how we go from negative 10 to negative 12, remember that we're actually not adding 2 here, so be really careful with that. We are not adding 2, we're actually subtracting 2. And so D is going to be negative 2. And so now take a look at number 3, right? If we're trying to figure out who's doing this correctly, we have that Richard is saying, hey, our common difference should be negative 12, and Maricela saying, well, no, it should be positive 12. And so let's take a look. If I have negative 44, and I'm curious on how we go to negative 32, well, what I'm really doing, right, and the math that we didn't really show up above, was I'm actually taking that negative 32 and I'm subtracting the negative 44, right? If we think about the example up here, if I wanted to know how I went from 5 to 8, well, I take that 8, subtract 5, and that's how I got that 3. And so if I have negative 32 minus a negative 44, that's a 4, apologies, my pencil doesn't like to play along always, I find that I'm actually going to have a positive 12. And so I would agree with Maricela that we are actually going to subtract the first term from that second term, or from the next term. So we're going to do previous minus current to find that. Another quick way we can see is, take a look. This actual sequence, we're approaching 0, and so we're actually getting more positive as we go. If we're getting more positive, well, that means that our common difference would have to also be positive, which means that Richard would just be sort of like doubly wrong, right? It couldn't be negative 12 if we were still continuing to move up on that number line. All right, feel free to pause. And once everybody has this, we're actually going to jump back into our notes for that last example. All right, and so example 2, we're going to use this sequence, negative 7, negative 2, 3, negative 8. Apologies, we're going to fix this right now. That should be a positive 8. Positive 8, there we go. And so we're going to have negative 7, negative 2, 3, 8. Let's check. How am I going from term to term here? Well, it's going to be plus 5, and plus 5. Perfect. And so a few things that I can already start to identify, right? If we think about that equation that we made up above, this a sub n is equal to a sub 1 plus n minus 1 times d. I'm going to need to identify those pieces for this. And so I'm going to have the a sub 1, well, it's just whatever number shows up first in my list. And so that's going to be negative 7. D is going to end up being whatever I'm adding to each term to get to the next, and so that's 5. From here, I can start to build this equation. And so for part A, the general form, I'm going to have a sub n is equal to negative 7 plus n minus 1 times 5. Now, a few pieces that I quickly want to highlight. When we're doing this, let's go with this. When we're working with this, notice that a sub n and n both end up staying when we're talking about the actual equation. Even when we move from general form to sequence specific, those stay. And the reason for that is I still actually just don't know those, right? Finding this term value is going to be dependent on what term number I'm actually on. And so, for example, right, part B says, okay, well then find A sub 22. And so for part B, what this is really saying is that n is going to be 22. And so A sub 22 is going to end up being negative 7 plus 22 minus 1 times 5. Just working this out at this point is really just arithmetic. 21 times 5. 21 times 5, well, it's going to be 105. And so I'm going to have negative 7 plus 105. And so A sub 22 is going to equal 98. And so now I'm going to end up moving some of this here just to give myself some more space. What we have to look at now, right, is part C. And so part C is going to now ask us, well, hang on a second. It's great that we can plug in n and find a number, but what happens if we actually don't know what number this is in the sequence? I know that this 248 pops up somewhere, I just don't know where. And so for this, we're actually going to change up our approach. And so for C, I know that this piece right here is what I'm actually going to end up substituting in for A sub n, right? I'm not just replacing n, I'm replacing the entirety of A sub n. And so I'm going to have 248 is equal to negative 7 plus n minus 1 times 5. I need to keep this n because really what this is asking, if I'm looking for a term number in the sequence, I'm trying to solve for n. And so I'm going to add 7 to both sides. Find that 255 is equal to n minus 1 times 5. Let's divide everything by 5. Those will cancel. We'll learn 255 is going to end up being, divided by 5 is 51, which is equal to n minus 1. Going to add 1 to both sides to learn that n is equal to 52. And so for part C, this 248 is really n sub 52, meaning it's the 52nd number in our list or our sequence. I'm going to leave this here for a second. Pause the video if you need, but then we're going to jump into problem set B. All right, taking a look at problem set B, you have 2 questions. Only 2 questions. You're going to have hopefully about 4 minutes. Whoever is filling in for me is going to have a better grasp of time depending on how long we possibly needed things paused. And so go ahead, get some practice time on problem set B, and when you finish up, I will quickly go over both of these questions. Go ahead and get started. All right. So, taking a look at problem set B, we're going to start with number 2. Now, we're being told that Letitia is beginning an exercise program that calls for 20 minutes of walking each day for the first week. Okay. And so instantly we have that 20 is specifically the first week. We know that first values are important here. Each week thereafter, she must increase, well, hang on a second. We know that increase generally means add her walking by 7 minutes a day. Which week of her exercise program will be the first one in which she will walk over an hour a day? And so let's take a look. If we're walking over an hour a day, right, that really means we're walking at least 60 minutes. And so the way that this problem is set up, it's actually asking us a question that's more similar to part C in our notes. And so I'm going to start by sort of beginning to set up this equation. And so I know that a sub 1 has to be 20. It's that first week value. And I also know that my common difference is going to end up being 7, right? It's that amount that we have to increase this every single day. Or sorry, every week. And so if I go to create my equation, I'm going to have that a sub n is equal to 20, there it is, plus n minus 1 times 7. Okay. Well, from here, let me zoom in a bit. Much better. From here, right, I'm looking, this 60 is actually going to be an a sub n value. And so I'm going to substitute it right in for there. So 60 is going to be equal to 20 plus n minus 1 times 7. This setup itself is going to look really similar to the last one. And so I'm going to subtract 20 from both sides. Learn that 40 is equal to n minus 1 times 7. Divide both sides by 7. And now, this is where we have to be careful, right? Because we know for a fact that 40 divided by 7 isn't going to be a nice value. And so if you put this in your calculator, what you're going to find is that 40 divided by 7 is going to end up giving us 5.71, we'll call it. We'll round it. That's going to be equal to n minus 1. Now, I'm going to keep going, and we're going to talk about why. I'm going to add 1 to both sides and learn that n is equal to 6.71. Now, remember, n is actually a number of weeks, right? If this 1 is the first week, that really means that n is number of weeks. And so if I'm only increasing my time at the end of a week, well, what that really means is that I should be hitting 60 minutes somewhere in the middle of the 6th week. But that's not quite going to be how we want to look at it. And so what I'm actually going to do is end up rounding this value up and say that n, we're going to call this, should be rounded to 7, meaning that after the 7th week, Letitia will walk more than 60 min. All right, and so from here, depending on time, whoever's filling in can either quickly show my answer for question number 3, or you can just jump straight to your exit ticket. There is going to be no homework tonight, and I will be back tomorrow to talk to everyone about how today went. Hopefully you were able to get through most of this packet, but go ahead, jump to your exit ticket, and have a wonderful day. I will see you tomorrow.